Right. So I'll spend a few minutes on telling, sort of sharing with you how I feel the field of AI has evolved over the last 18, 15 years or so. So work on AI has been on since the 1950s, or yeah, I think even from the 1930s and 40s. And there was a lot of traction in the field during the 70s and 80s. But then was a prolonged period, which is known as AI winter, where not much funding was there in AI, and there were not many real world applications of AI. So if you fast forward to 2018, what changed is that since the early to late 90s we have internet, a lot of internet enabled devices, and from 2005 6 onwards we have smartphones since iPhone came onto the market. So all these devices, whether it is smartphone or or online websites, etc., we are now generating a lot more data, and that was a key bottleneck to training big AI models in the 80s and 90s. And what has additionally happened in parallel is that it has become much cheaper to store data. Earlier, I remember carrying data in floppy disks and CDs and burning it in DVDs. Now, everything is on cloud. We use Dropbox, Drive, and other such solutions, right? So it's become easier to store data, access data, and at the same time, it has become easier to use technical hardware to train AI models using cloud technologies. So the barrier for entry into sort of developing AI has come down drastically, right? And one of the key hardware that is important for training AI models is something called a GPU. So initially, a company called NVIDIA pioneered GPUs to enable video gamers to play the games faster. And then some researchers realized that this is a very interesting technology, and can be used actually to train AI models much faster than on CPUs or computers, personal computers. So 2008-9 was the period when this started taking off, and then in 2010, I think, was the first paper that showed that deep learning solutions are better than the previous state of the art. So that was kind of a landmark moment, and it was a paper focused on speech recognition from the lab of Geoffrey Hinton, who's a well-known pioneer in the field. And then that kind of kickstarted the onset of the deep learning revolution that we are in today. So now we have a lot of data sets, huge data sets on, let's say images or text or audio or video now. And we have a lot of benchmarks also, which is important to validate how good the different AI models are. And additionally, over the next 5 years, what has happened is that a lot of models became established as standards in the field. So let's say if you want to build a model for image recognition, you can directly start with a model called ResNet and just start using it off the shelf, and that is already delivers pretty good accuracy. And then you can use techniques like transfer learning to transfer the learning from that model to your particular use case. Let's say if you're looking at a face recognition application, which is typically trained on a lot of faces all over the internet, predominantly from the Western world. And if you want to change it for deploying face recognition in India, then you take a subset of images of Indian people from across the country, and then you can fine tune a pre-trained model without actually having to train a model from scratch all over again, right? And then the other thing that is very recent is that it has become possible to train exponentially big models. So you might have heard of GPT-3, which was released over the last year. And this is a model that is used for NLP or text applications. And if you're able to provide certain seed words or a short input, it can generate like the next sequence of text to come. So let's say what it does, it captures a lot of information of text present from Wikipedia and a lot of other text databases and data sources out there. And it is almost like a huge brain in itself. So that if you show one or two examples, the model can learn to generalize and predict text and generate different kinds of text as well. So that has been a very exciting moment in AI just over the last year.